Welcome to ZT classes.
Let's see the question. So the angle of elevation of a cloud from a point h meters above the surface of lake is theta. So we have got a lake is there and a cloud is there, and its angle of elevation is measured h meter above the surface. So let's say AB is the height h meter, and from point A the angle of elevation is measured. So from point A we'll first draw the line of sight, and then the angle of elevation that's given as theta. And the second part is the angle of depression of its reflection in the lake. So reflection of the cloud is there, and this angle of depression for this from the same point A. So we'll draw the angle of depression. So this is the line joining it, and phi is the angle of depression which is given. You have to prove that the height of cloud above the lake is this. So for that we'll join the cloud and its reflection, and here this line is perpendicular to the line of sight, and you have to find the height of the cloud. So here the height of the cloud is Pn. Let's take it as x, and by the property of reflection NQ will also be x. So we have to prove that x is equals to h times of tan phi plus tan theta upon tan phi minus tan theta. Let's see the solution. So here what is given is that P is the cloud and point Q is its reflection in the lake. A is the point of observation, and AB is h. Angle PAL, that's angle of elevation, is theta. Angle LAQ, that's angle of depression, which is phi. Here we have to prove that the height of the cloud is h tan phi plus tan theta upon tan phi minus tan theta. Let's see the proof of it. So let the height of the cloud above the lake is x. So here if you will see, again we have got two triangles are there, right? Two right angle triangles, and you have to use these two triangles to get the value of x. So these two triangles are there, and you have got something common between them, that is AL is common between them. So we'll first take the triangle APL. Here AL is unknown, but this PL is nothing but x minus ln, and ln is same as h. So basically your PL will be x minus h. So in this triangle we'll find the value of AL in terms of theta and x minus h. Same way the second triangle we'll use is triangle ALQ. Now in this triangle ALQ, this QL is given as x minus x plus h, right? And AL is unknown. So both the triangles, we have got these angles are there, and the sides are given. AL is unknown, and this AL is what we will compare to get the value of x in terms of h. So let's take our first triangle. So the first triangle we are taking is triangle ALP. So we'll use tan theta. So tan theta is perpendicular upon base. Here the value of PL, that is x minus h. So we'll put that value. So we'll get tan theta is x minus h upon AL. And let's find the value of AL in this. So AL is coming as x minus h upon tan theta, right? Now in this second triangle, AL is known, right? AL is known, LQ is known, that is x plus h, and we'll compare, we'll find the value of tan phi. So second triangle I am taking is triangle ALQ. In that tan phi is equals to perpendicular upon base. Let's put value of LQ. LQ is nothing but x plus h. And in this, let's put the value of AL, right? We have got this value of AL with us. Let's put this value here. So we are getting tan phi is equals to x plus h upon x minus h upon tan theta. So simplifying it, we'll get x minus h times tan phi is equals to tan theta into x plus h. Let's take the terms with x on one side and terms with h on other side, right? So simplifying it, we'll get value of x as h times tan phi plus tan theta upon tan phi minus tan theta, and that's the height of cloud, and that's our answer, and hence proved. I hope you enjoyed the solution. Keep watching.